My dear students, today we are going to discuss about electrolysis reaction. So let's get into the reaction now. In an electrolysis setup, oxidation take place at the blank and reduction take place at the blank. So we need to learn about the oxidation and reduction. Before that, we need to know about the basic knowledge regarding to the electrolysis. Therefore, now I am going to draw the electrolysis setup. Step by step, we are going to learn about what are the major components of the electrolysis setup and what are the reactions which take place inside of this electrolysis setup. So let's get into the drawing. So I'm going to draw electrolysis setup. Now we're going to learn about what are the three major components of the electrolysis setup. Here we're going to name each part of this. So as you can see in here, so these two rods we known as in electrolysis setup as electrodes. So as you can see in here, how many electrodes are there? There are two electrodes. So what are the two electrodes? So you know, so as you can see in here, there is a electric source. That electric source connected with this two separate electrode. So as you can see in here, so this is the positive terminal of the battery. This is negative terminal of the battery. The positive terminal connected with this rod, therefore this rod we known as positive electrode. Okay, so what is this? This is the electrode which connected with the negative side. Therefore, we writing it as negative electrode. Negative electrode. So, positive electrode we are going to name as anode. We are using a special name to name the positive electrode. What is the name that we are using? Anode. And when you take negative electrode, here we name it as cathode. When you selecting an electrode, there is a very important thing that you need to consider. What is that? So this electrode can't chemically react with this ionic solution. That is really important. Therefore, when we selecting electrodes, we should have to select ionic, inactive like carbon, platinum electrode for this purpose. And when you take this solution, we are going to name this solution as very special name electrolyte. This should be ionic solution. And the next component in here is electric source. So, what are the three major components of this electrolysis setup? Electric source, electrodes. How many electrodes are there? There are two electrodes are there. Positive electrodes we known as anode, negative we known as cathode. Then, when you take in here, the solution we known as electrolyte. So, here we are going to write the three major components of electrolysis setup. Electric source, second one, electrolyte, third one, electrode. Now, under this reaction, you need to, there's a two special terms they given as oxidation and reduction. When you come to the oxidation, what does mean by the oxidation? So where the oxidation is occur, so that kind of a problems you may have. So look at here. The chemical reaction which take place in anode we know as oxidation. The chemical reaction which take place in cathode we know as reduction. So, now let's get into the question. Now you know the chemical reaction which take place in anode we know as oxidation. The chemical reaction take place in cathode we know as reduction. So let's read now question. In an electrolysis setup, oxidation. Where is the oxidation take place? Anode. So here I am writing anode. And reduction take place at the reduction take place in cathode. So I'm going to give you a small trick. What is this? When you go to the exam, this is really important. Sometimes in your examination paper, they might give you a setup to mark the anode and cathode. They are asking about what is the oxidation, what is the place that oxidation take a place and reduction take a place. On that time, most of the students messing up this point. Therefore, I am giving you a small trick to remember this. So what is it? Red cat. Reduction take place in cathode. And ox. Oxidation take place in anode. Again, I am getting to the trick. Reduction take place in cathode. Red cat. Anode oxidation and ox.